So TGIF, thank goodness it's Friday. So we made it through the first week. Again, there's not homework on Lumen Learning. However, I do expect to assign homework on Monday, which is February 1st. And then that homework will be due the following Sunday. So if you can't get onto Lumen Learning, please let me know, okay? Please. I will have, one second please, and I will also have office hours today too. I'll send out the link after class. Okay. I will do that. I was gonna say, I think that's it. Okay, let me just stop sharing my camera and then I'll share the notes. Okay, I think someone had a question. Yeah.
When I made my account a few days ago, there was an assignment on there. It said like it was due in May. Do we have to do it, or is that just the account?
Does it say like assignment 0 or something like that?
I don't remember exactly. It didn't have a due date until May, so I wasn't sure what
Oh,
it
someone
was.
says it said it does have its assignment 0. You don't have to do that. That's not for your grade. Yeah, assignment 0, no points. That's just there to get you acquainted with Lumen.
Okay, thank you.
You're welcome. Okay. Okay. All right. Thank you. All right. Any other questions? Okay, let's get, so here are the notes. I did email them to everyone. So let's get started. All right. Okay. Okay, so, all right. So last time what we did, remember, was we saw monomials, okay? And again, with monomials, those are terms of this form, a times x to the k. They're monomials in the variable x, Okay? I mean, for the most part with us, we're going to focus on the variable x, for us at least. But you really could have different variables if depending on the situation or depending on, I guess, the context. And now a, remember, is a constant, a fixed number. Now, if a is not equal to 0, then the idea is then k, we call that the degree of the monomial. We call k the degree of the monomial, okay? And remember, k can only be a non-negative integer. With the convention that if k was 0, then you don't write x to the 0. I mean, in a sense, I guess you could treat it like 1, but remember, that's really not precise to do. So what am I getting at? Well, any non-zero constant is a monomial of degree 0. And if you have x raised to an exponent, right? Again, the exponent k, then k is called the degree of the monomial. And also, if a happens to be 0, okay, well then the whole thing is 0. 0 times anything is 0. In that case, the monomial has no degree. The monomial in that case has no degree. Again, that's just a convention people take, so that's just monomials. And these are just some other examples. I know we did a few last time, but I figured it'd be good just to do a few more. So x to the 4, right? That's a monomial, and it's of degree 4, right? That's what the exponent is. The coefficient 1, okay? This coefficient here, it's not written, but it's understood to be 1. Remember, it's just like with exponents. When the exponent is 1, we don't write it. It's the same idea. So if you have a variable here and you don't see the exponent, the coefficient, then it's understood to be 1. Okay. So this is, again, degree 4. 5 alone, that's a monomial. Now 5 is non-zero, right? So its degree is 0. So we have a monomial there of degree 0. Excuse me. 5x to the 8. This is a monomial also. This is a monomial of degree 8. Okay, that's what this is, a monomial of degree 8, because the exponent of x is 8. 5 here is the coefficient. Notice here I have x to the pi. Well, this is not a monomial, right? Because pi, remember, is not a non-negative integer, right? Pi is a decimal. It's an irrational number, actually. It represents an irrational number. So we don't have a monomial here. I threw this in, I guess, for fun, so. So those are just some more examples. And this was also something we saw last time. I just wanted to bring it up again just for a review. Remember, we have this notion of like terms. Two monomials, remember, in the same variable with the same degree, right? Those are called like terms, okay? Two monomials in the same variable, right? With the same degree, you know, the same exponent of x, we call them like terms. And like terms matter because those are the terms we can combine, right? We combine them, meaning we add or subtract, by adding or subtracting coefficients. The power of x does not change. I know it looks like we're factoring out, but we're really not doing that. This is just a rule telling us how to combine like terms. And if they're not like terms, they're unlike terms. Again, this is what we did last time. So just as a refresher, so to say. But now for monomials, we can consider polynomials in the variable x. And as you can see here, well, really, I wrote it out as well. It's just a sum of monomials in the variable x. That's all it is. You have some monomials and you're just adding them together. It does turn out that you can write it this way, as you can see, where, as you read from left to right, the exponents of x, right, they're decreasing as you go from left to right. This is actually what we call standard form. This is actually what we call standard form. Again, as you read from left to right, the exponents of x get smaller. Okay. Here's some more terminology as well. Basically, let me just say this actually. The first thing here, what it's trying to say is that the largest exponent of x, that's called the degree of the monomial. That's just the degree of the monomial by definition. I know it says if a sub n is not 0, they're just really being technical here, because if a coefficient were 0, we wouldn't write the term. You know, we just wouldn't write it. And the term where the degree of the polynomial, that is the term where the exponent of x appears, we call that the leading term. That's called the leading term. And the corresponding coefficient there is the leading coefficient, as you can see. We have this term here, there's no variables there, right? That's called the constant term. It's called the constant term. Okay? Good. Okay, so that's what a polynomial is by definition. So I figured it's good to see some examples of these things. Here we have a polynomial, right? 6x cubed minus x plus 2, right? Notice the biggest exponent of x, is 3. So this is of degree 3. Okay, this is of degree 3. And also, the leading term is 6x cubed, right? Because again, that's where the highest power of, the highest exponent of x appears. The leading coefficient, as you can see, is 6. The leading term is 6x cubed. The constant term is 2. And also, there's no x squared term, as you can see, right? There, I guess it's understood that the coefficient of that is just 0. So we don't write it. Someone asked me this in my other class also. If you do write 1 as the coefficient and the exponent, even though technically you don't have to, but if you did write 1 as a coefficient or exponent, I'm not going to take points off. That's going to be okay. I feel like at this level, that's fine. So, all right. For this polynomial here, 4x to the 5th plus x cubed minus x squared plus 1. That's a polynomial also. Right? That's a polynomial also. Namely, 4x to the 5th, right? Well, that's the degree of this is 5. That's the biggest exponent of x. The leading coefficient, as you can see, is 4. The leading term, is 4x to the 5th. That's where the biggest exponent of x is. The 4 is the leading coefficient. And the 1, as you can see, is the constant term. The 1 is the constant term. Down here, we have 12x to the 6th plus x squared. This is of degree 6. The leading term is 12x to the 6th. 12 would be the leading coefficient. The constant term is 0, right? It's not there, so it's understood to be 0.